Good afternoon. Welcome back to my channel. Okay, just a recap of what we have covered so far. We have looked at the OSI 7 layer model up to first and second layers, up to second layer, and we looked at devices, hub and switch when we're doing the comparison between the two. Okay, so now as a connecting point, we are going to introduce a router. Why? Router is going to be residing at layer 3. So router is a layer 3 device, but we want to see now the relationship between a router and switch. A switch is a device which we said operates in a network segment. So which means if it is intra-network segment communication, a switch is going to operate very well. Network A, devices communicating amongst themselves, the switch is going to operate well. But now if it involves network A communicating to network B, then a switch is not going to be applicable here because it involves routing. So now we call the services of a router, which means now the switch is going to forward information to the router, then the router is the one that directs the packet to where it is needed, to where it needs to go or to be forwarded to. So a switch is going to depend on the services of a router to be able for information to be sent from one network segment to another network segment. So that capability to forward the traffic from one network segment to another network segment requires the use of a router. And for a router to be able to perform that task, it has got to read the IP header file, inside of which the IP header file we find the destination IP address. So a router is going to check the destination IP address and refer to its routing table in order to make a forwarding decision by choosing a path to the destination. So what does the router do? It simply looks to see if the best route is present in the routing table to forward the packet to. If the route is not there, the router discards the packet and send a destination not reachable message back to the source. So that's a router for you. So far, what we discussed, a router occupies layer number 3 and it reads IP address, refers to its routing table. What is in the routing table? The best path to the destination. Router also supports VLANs, inter-VLAN communication. That is to say, if the source VLAN was VLAN number 1 or number 2 and the destination is VLAN 3, then traffic would pass through the router to go to the destination VLAN, since the switch cannot link two different VLANs together. By the way, for that to occur, the router has got to use a very specific protocol called encapsulation.1q protocol to forward the word to be configured on sub-interfaces. To be configured on the sub-interfaces on the default gateway. On the default gateway, let's talk about the router now. The router has got what is called a default gateway. What is a gateway? What is a gate from your house? How do you understand? What do you understand by a gate? This is the way in and out of the yard or out of the yard where your house is. So there we are, a gateway, default gateway. This is the only way we pass through from a network, from a network or into the network. That's the word default gateway. I'm just simply looking at the relevance of the word gateway. Into and out of the network segment. That's the router for you. So we see it being a default gateway for a VLAN, for a network segment, to allow packets to leave a network segment and also get into the network segment. That's a router for you, and it is found at layer number 3. So by doing that function, we say it is routing. We say it is routing. So what? So we see the relationship between a noun and a verb here. A noun and a verb. We have got what is called hierarchical network design, which is made up of 3 layers, by the way: access, distribution, and core layer. So we see a router occupying distribution and core layers. Access layer, by the way, that's where we find the switch. What is access? What is access in its literal meaning? Access is a word that allows access devices connectivity into the network. So those are the ports on the switch to which we connect endpoint devices, so that they can be able to connect to the network. Hence the word access. If one PC needs to communicate to another, they use those RJ45 ports on the switch, and it is at layer number 2. That's access. Distribution, we are now distributing between one network segment and another. That is now routing. Routing can extend to the core layer, where now we are now routing from the from the enterprise network to the public space, ISP and internet. That is now core. So our router can be found at the distribution, as it distributes traffic within enterprise network and routing traffic out of the enterprise network. That is routing as well. When a router is right there, situated at the edge, at the enterprise edge point of our network, at the perimeter, then that router has got more functions. It is also going to be configured with NAT to separate the private IP address from the public. So NAT is a concept that was brought by IANA, Internet Assigned Numbers Authority, to separate private IP addresses from the public IP addresses in order to conserve, in order to delay the depletion of public IP addresses. So public IP addresses are reserved, not given to private networks. No, unless it's a special circumstance, but not just given to private IP addresses. Private networks. It is reserved for public IP addresses. That's public. Reserved for public networks. That is a public IP address is distributed or given by IANA. Okay. So we have NAT, which is a separation point between the internal network and the external networks. Also, on the edge device, we see the configuration of a default static route to the ISP. We see the configuration of a default static route to the ISP, which allows all the internal network to be internal packets to be channeled into that default static route, pointing to the ISP, pointing to the ISP. So a default static route is configured by the network administrator or network engineer to allow the forwarding of packets to the ISP. Remember, it's directed. It writes a statement which directs traffic to the to the ISP in the routing table. Then no neighbor adjacents is formed between the edge router, our enterprise edge router, and the ISP. no routing updates are exchanged between. Remember, in routing updates, we've got what are called hello packets and update packets. So which means on that router, which is our edge boundary router, it's configured with default static route pointing to where? To the ISP. In the enterprise network, we see a number of routers being set up. Remember, an enterprise network is a very big network in size. It can take the size of a general hospital, or it can take the size of a government department, or a university, national universities. So we are looking at a very big network. So we can't have one router, but we've got a number of them. Remember, we said a router can be found to be operating at network layer, yes, or distribution layer of the hierarchical network design, which then allows the distribution of traffic, of network traffic between departments. But let me say this. At distribution layer, the most appropriate device to apply there is the layer 3 switch. Why? Because of the number of the ports on the switch. A switch generally has got more ports than a router. So one take advantage of a layer 3 switch port density as well as the switched virtual interface. Switched virtual interface to support VLAN. The switched virtual interfaces support inter-VLAN routing. Remember, we said inter-VLAN routing is occurring at distribution layer of the hierarchical network design. So that's a router for you. A router is going to be found at distribution and core. Let me add this point as well before I end. A router can also be, as an edge device, can also be configured with virtual private networks, as we configure tunnels like this, virtual tunnels between the current enterprise network and a remote network, which can be a branch network or a remote site network, and a virtual tunnel is going to be formed between the current site and another site. Hence, we call it site-to-site VPN. So which means our edge router becomes VPN intelligent device and another VPN intelligent device, or a VPN enabled device and another VPN enabled device. Together, they authenticate and exchange secret keys. By so doing, they create a tunnel, and whatever is forwarded is encrypted using IPsec and GRE, generic routing encapsulation, or IPsec for Internet Protocol Security. These are VPN protocols, by the way. I would love, guys, if you can dig deeper in terms of how they operate, how they are configured. So that's what. That's our edge device being a router. But we can, this is very important to say, we can have a firewall in a router. So we can have two in one, firewall and routing. Functions combined together. It becomes a one-stop shop to achieve the security architecture as well as the routing. So there we are, we've got our router, and we're going to discuss more in terms of the routing protocols that can be configured in the ISP. Oh, by the way, a router can also be found in the ISP. Remember, an ISP is got what is called a core network. So a core network can be expanded and contracted. So if we expand a core network, what are we saying? We are adding more routers so that they take a larger space. Maybe they go nationwide. So what if is happened there? The expansion of the network itself by using layer 3 routing. Of course, it can be designed on the layer 2, but layer 3 is the most efficient. Routers can also be found operating where? In the cloud. service provider. But in the cloud, you know, the preceding word becomes virtual. So we can have virtual switches, virtual routers, virtual everything in the cloud. So, okay, fine. Guys, that was our lesson. We look forward to join again on the next topic to be announced. Thank you.